Welcome to another GCBASIC demonstration. This is for the AVR DX. It's called ACD operations. I spent the last day adding ACD operations to this development program, and ACD operations are quite important, as it will become apparent, because they measure things. So what am I going to be using today? I've got a AVX DX board. It's a C Nano. The one I'm using happens to be a Mega 4809. And I'll show you my desk so you can see it desk cam. Here it is. It's laid out here in red, and I've got a potentiometer next to it. And I'm going to read this potentiometer here, and I'm going to adjust it with my ready screwdriver. And essentially, I'll go into the circuit that I'm using, but that's, pretty simple circuit, but very important. So A to D, or analog to digital, is really converting a digital signal into an analog signal. It's like a potentiometer, sound picked up from a microphone, cameras, etc. And I'm going to be using a potentiometer. And I'm going to configure the ADC on this Mega 4809 to run a conversion, read that analog voltage that's coming through the potentiometer, and display that on a serial terminal. So let me just click on the right screen. So this is a board I'm going to be using, and I put a big red ring around it because there are 8 different ports that we can choose from here. And it's sort of important to know those 8 ports because they're not available on the many ports that are available on this particular chip. I'll go somewhere else. I should show you really a diagram really maybe. That would help. This is the Explorer pinout diagram for Microchip chip, okay? And anything that's green is what's called an ADC port. So you can see on the one that I'm using, it happens to be on this area on the right-hand side of the chip. On the chip on the right hand side, they look to be in a similar position. If I cursor down, you can see similar positions, but let me reassure you, on the 1627 they have completely different names. And those names are inverted to completely different names on the 1627 series. So you have to come to these diagrams and understand the connections. 3217, they have similar names, but they have 2 names. And so this complexity really needs to be simplified, and that's what we do in GCBASIC. We're going to simplify this down. If you know the name of that green thing, it will work. So I'll go back to my PowerPoint and I'll dig into that deeper. So I'm going to focus in on this on these 8 here. There are 8 ports on this particular chip, and they happen to be hooked up to PD0 to PD7. And all you have to do in GCBASIC is specify the green thing, the green name, AIN0 through to AIN7, and the intent is that it's all handled for you, that the configuration of the port, which is quite complex, is masked, and it's just very simple. So what I've got attached today is a potentiometer to IAN1, and I've got it connected to a 3-volt supply to the middle pot on the potentiometer on the brush, and then we go down to ground, and we can see that on the camera. What we've got here, I'm taking a red wire to one side of the potentiometer from the 3-volt supply on this board, 3.3. I've got a ground to the ground, and this blue wire goes to port AIN1. Does it? Well, we'll see in a moment. And so it works quite well if you know that simple circuit. That simple circuit is a supply, a ground, and take the measurement off the brush. And that will give you the voltage. So what we're going to do is we're going to initialize it. We're going to do it forever, and we're going to read the ADC. It could be a 10-bit or 8-bit read. We're going to send that value to a serial terminal, and then we'll wait and just do it again. So on the right-hand side, there is a flow diagram. So So what we're going to do, we're going to look at some sample code, review the results. We could change the microcontroller because it's portable code. The same code works on different chips. And then I might have to revert the code because this is the demo set of code, okay? So let's go straight into some code and have a look what we've got here. Well, what I've got on the screen is a terminal. And you can't see that terminal yet because I'll bring it in for you. And here's that terminal. It's ticking away and it's got a value on it, okay? And you can see that that value is currently 38. If I go into Zen mode, oh, there we go. There's Zen mode, look. I'll bring that across to there, look. If I rotate the pot, I get a range. I get a range from, what's that? 1023, I rotate it around and I get to 0. And that is called a 10-bit number because the number 1023 is made up of 10 bits. And so that's what we're going to do. You can see it on the screen. It's on the terminal, relatively simple. So let's look at some code. I've got some code on the screen here. I will bring it in so that you can see it quite clearly. And I'm going to keep this in Zen mode so that you can see what's going on. I call it Zen mode because it's Zen-like, I guess. Okay, I will have to shuffle things about a little bit, but I think that's good enough for military work. That is the whole program. So what we're going to do, let me just make sure you can see it. You can't quite see the top, so I'm just going to drag it down a bit. There we go. That's the whole program. Whole program. It's very simple. Okay, I specify the chip and I specify option explicit, and that just defines the chip. If I wanted to change the chip, I would change that, and it automatically takes it to the fastest frequency. If I wanted to change the frequency, I would type a number behind, like whatever is a valid frequency for that chip. I've set up the serial, and this is all I need in GCBASIC to set up the serial. I'm using the CDC in this C Nano board, and those are the three configuration items that I'm required to set up the baud rate of 9600, and that's what I was using in the terminal. Then we get into the program. I say wait 100 milliseconds and put some text on the screen, ADC read, and then I do my for next loop. It's a loop, it's a do loop, it does it forever, and it says here read the AD10, a 10-bit number, and I pass it a constant of AIN1, which equates to the ADC port that I'm reading. In the background, it will set up the pin for you, it will set up the inputs, it sets up all the configuration to make that read AD10 work. And then it does a print carriage turn line feed and waits 100 milliseconds. So in my keyboard here, I can press function key F5 and it will program that for me. And we'll go straight out to the terminal and we'll see the terminal. It said very quickly, it said and passed very quickly ADC 10. So maybe I should go back to my program and we'll put a bit more of a delay in there so we can see it. I'm going to change the program. I'll just get rid of that programming window for us. I'm just going to put that in here for a little wait there. Wait 4 seconds just so we can see it. I'm going to press function key F5. I can press function key F4, and then I've got a list in here, and I can type in MAK, make hex and flash, which is the same as function key F5. So it's compiling it, and it's now just past it there. It says ADC read, waits a few seconds, and that is the conversion. Now in AVR, the first conversion is always 0, so we saw that go past. You should throw that one away. And then if I rotate it, it's doing exactly what we expected. So how do I change this to an 8-bit read? Well, we look at our source code. Quite clearly in my source code, I'm doing a read AD10. And if I go into the help by pressing function key F1, I'll have to go to full screen for this for you. There's a whole page on READAD10 and how it works. But essentially, we've got READAD10 and you pass it a port and then it puts it in a variable, a word variable. Well, let's do the same, but this time we're going to do it for a byte variable. So here, READAD10, I'm going to just take the 10 out and it will change it to an 8-bit read. Let me do this for you out to our terminal and we will see it pop up ADC read. It will wait 4 seconds. And now we've changed it into an 8-bit read. And if I put it onto minimum, 0, and an 8-bit number is 255. There we go, 0 to 255. So we have completed a full operation. Now we can measure things. With the previous programs I've shown, you could then write a data logger. You can do many different things once you know how an ADC reads works. And there's no configuration of the port. That's done fully automatically for you. And if you want to review how that works, you can look at the assembler. It's fully documented to explain how it works. So our program, relatively simple, just a simple do loop, reads that AD and prints it on the screen. And you could write a data logger very simply. Now, I said that I was going to change it for a different chip. If I wanted to change this to a Mega 328p, well, this doesn't exist. This constant doesn't exist. I think it's called ANA 0. We'll try that. Do it from memory. And if I recompile it, it generates a completely set of... Oh, how about if I put in the proper name? That would help. It would generate a completely different set of assembly and a different hexadecimal file, and it won't work. Oh, it's also telling me there's no UART3. That's quite intelligent, right? So on this particular chip, there's only one UART. There's a 3 on the one, and there we go. We've completely rewritten the code for a different chip. So these commands are portable. And if I change this up here to a PIC 16F866, that's not a valid chip, is it? 866, it's not a valid chip. I'm doing it from memory. 866 is a valid chip. It's now written. Oh, I need to put an F in it. It will now compile the same program, but for a PIC. Quite simple. Let me revert my program because I'm sitting in a demonstration set of programs, and then we'll put it back to what we had before. We'll put that back to 10-bit. I press the function key F5, goes out to the terminal. I did type something wrong in my program. Oh, MEM Mega 4809. And if I wanted to change the frequency, I would simply change the frequency, but I don't want to. UART3, this is my serial. Let's have a look what we've got. ADC read, and it's now reading it at 280, which is correct, by the way. So, very good, very simple. Go back to my slides. So I want you to enjoy that because it is extremely simple to read the ADC. So that's ADC operations for GCBASIC, September 2024.